All right, guys. So technically, yesterday would have been a snow day if you guys were in actual school, but since you guys were home, you guys had a snow day anyways. Just gonna go off a little rant here. I did not know how much Reddit or people on Twitter could drive the stock market. I just witnessed a stock go from $19 in the end of December, and it's up to $240 right now. That's the GameStop stock, the video game stock in the US, and AMC is also, yeah. So I no longer understand what the stock market does. So yeah, I might be forced to get into some AMC shares, but we will see how it does. I mean, no one saw this coming. It's a Reddit community where they hate the rich people. So yeah, they're just trying to make them all go broke, and that's why this thing is doing what it's doing. Okay, so yeah, unfortunately, I wasn't able to get into that AMC at a cheap price, but I mean, if it hits $10 today, I might just get in on it just because of the manipulation these guys on Reddit are doing. So I don't know. We'll see. We'll see. I just find it hilarious. Obviously, it sucks that I'm not making money off of these moves, but it is what it is. No one predicted this coming, and who knows what it's going to do today. So yesterday, you guys got to learn about instantaneous rates of change with the quotient, with the difference quotient. Today, we're going to look more into that as well. So we're going to be finding the average versus the instantaneous rates of change. What's different, what's similar about them, and we're just going to compare the two of them today. And also, for those of you who don't know what AMC is, we had one in Mississauga by Courtney Park. It's a movie theater. So it makes no sense that the stock is going up when they just basically had money lended to them so that they wouldn't go bankrupt. So like I said, I do not comprehend anything that's going on right now. I'm just as confused as everyone is. Okay. So the average rate of change of a quantity represented by a dependent variable occurs over an interval of the independent variable. So the average rate of change of y is equal to f of x over the interval x is greater than x1 but less than or equal to x2 is delta y over delta x, where f of x2 minus f of x1 is divided by x2 minus x1, or what you guys learned in grade 9 and 10 is y2 minus y1 over x2 minus x1. So as you can see here, this would be your tangent, and this over here would be your secant. Okay? And yesterday, you guys learned independently how to find the instantaneous rate of change using the difference quotient. So in the instantaneous rate of change of the quantity represented by a dependent variable occurs at a single value of the independent variable. So for example, if points A and f of A and q of A plus h and f of A plus h represent 2 points on the graph of y equals f of x, then the instantaneous rate of change of y with respect to x at P can be estimated using f of A plus h minus f of A over A plus h over minus A, or simply just f of A plus h minus f of A divided by h, where h is a small number, notably plus or minus 0.01. Okay, so because it's instantaneous, you want to find a point that is very close to the x value that you're trying to find the slope for. Which means that average rates of change can be represented graphically using secants, while instantaneous rates of changes can be represented graphically using tangent lines. So now we're going to get into a couple of examples. So example 1, we want to estimate the slope of a tangent line at the given values of x by calculating the slopes of a series of secant lines. So for the example of A, we want to find the instantaneous rate of change of f of x is equal to 2x squared minus 5x plus 3 when x is equal to -1, and we want to use the difference quotient method. So our difference quotient we have m of the secant line, because we're not finding the tangent line yet, is equal to f of x plus h minus f of x over h. So the x value that we're focusing on is 1, is -1. So we have f of -1 plus h minus f at -1 over h. And then what we have to do is sub in -1 plus h for x, and then just -1 for x as well. So we get 2 bracket -1 plus h squared minus 5 times -1 plus h plus 3 minus f at -1, which gives us -10, I believe. So 1, no, not -10, sorry. Two minus 1 squared minus 5 minus 1 plus 3. And now all we have to do is simplify this. So we get 2 times 1 minus 2h plus h squared plus 5 minus 5h plus 3 minus 2 plus 5 plus 3 all divided by h. And we still have to simplify more because the numerator is not simplified yet. So we get 2 minus 4h plus 2h squared plus 5 minus 5h plus 3 minus 2 minus 7, so minus 10. All divided by h. And then what you're going to do is collect your like terms, and then you're going to simplify the expression. So 2, 5, 3, and -10 all cancel out. So all we have to do is simplify for the terms that are remaining. So what we end up getting is -9h plus 2h squared over h. What can we factor out from the numerator? So we're going to factor out an h. So we're left with h bracket -9 plus 2h over h. And this we are left with h, sorry, not h. This is just equal to -9 plus 2h. So now we need to use this equation that we found and apply it to the slope of a secant. So we want to find the slope of a secant of 0.01 and the slope of the secant at -0.01. So we're taking 1 point from the left and 1 point from the right, technically. So we get -9 plus 2 times 0.01, and that gives us -8.98. And then we get -9 plus 2 times -0.01, which gives us -9.02. But because we have basically 2 points, we need to take the average of the two to find the slope of the tangent line. So slope of the tangent line at -1 is equal to -8.98 plus -9.02 divided by 2, which gives us a slope of -9, which means that the slope of the tangent at x is equal to -1 is going to be -9. Remember, you guys are not being tested on this unit, so this is just for your knowledge for next quadmester. So hopefully those of you who have calc next quadmester, hopefully you find this useful. So example B, we want to find f of x is equal to -3 to the x plus 4 when x is equal to 0 using the centered interval method. So our boundary is going to be x is less than 0.01, but greater than or equal to -0.01. So the centered interval method, all we're doing to find the slope of the tangent is taking f at 0.01 minus f at -0.01 and dividing it by 0.01 minus -0.01. So this is the centered interval method. So f at 0.01 gives us 2.98895. And f at -0.01 gives us 3.01092, all divided by 0.02. And when we take the average, or when we simplify the expression, we get the slope of the tangent is -1.10, which means that the instantaneous rate of change at that x value means that the graph is decreasing at that point. All right, and our last example for this lesson is f of x is equal to square root of 2x minus 1 when x is equal to 1 using the preceding and following interval method. This one's the most annoying one because it takes the longest. I don't think you guys use this in calc, but I'm just going to show you just in case you guys do. So for preceding, this means before. So we're going to look at x is less than or equal to 1, but greater than or equal to 0.99. Okay? So when you're doing the preceding, you're basically taking the point that is closest to the left of the original point. And in this case, it would be 0.99. So our delta y, we would just find f at 1 minus f at 0.99. And that gives us 0.01005. And our delta x, we take 1 minus 0.99. and that gives us 0.01. And now we can find delta y over delta x, and that gives us a value of 1.005. And then we have to do the same thing with the following. So what would the following interval be for x is equal to 1? So we're going to have x is greater than or equal to 1, but less than or equal to 1.01. So same concept, delta y is f at 1.01 minus f at 1, and that gives us 0.00995. And our delta y remains the same, 0.01. And when we find our average rate of change at that secant point, we get 0.995. And now that we have the two slopes, all we have to do is add them together and average them out. Therefore, we have the slope of the tangent is equal to 1.005 plus 0.995 divided by 2, which gives us 1, which means that the slope of the tangent at x is equal to 1 is just 1.
Could you quickly scroll up above this?
Is that fine?
Yeah, thank you.